Hello everyone, myself Abhishek Pawar, pursuing BE in Automobile Engineering from Saraswati College of Engineering, Kharghar. This is a paper presentation on the reduction in steering effort of F9 vehicle. Let's get started with the abstract. The work focuses on the general steering arrangement on the basis of design synthesis and analysis of steering system. There is a significant role of the steering system in each and every vehicle to make the handling convenient according to driving conditions and to enhance the stability of the vehicle. Aspects like wheel, steering geometry, steering assembly plays an important role to improve vehicle handling. Considering different steering modes changes the need of steering system of Formula 9 vehicle. This begins with the actual design of Ackermann steering system, Ackermann steering geometry, steering components and their integration together in SolidWorks, followed by the technical specification of the final design. Steering is one of the most vital subsystem of any vehicle. In case of Formula 9 vehicle, it is even more significant since this vehicle is designed to compete in races and the objective of the team is to win. Any failure in the system will lead to disastrous effect to the vehicle and the driver. The driver must be able to control vehicle. The steering effort is an important characteristic of vehicle because it influences driver comfort directly. Vehicle effort and steering feel are the interest of this topic. Although designing starts with study of parameters which forms the foundation for designing the steering system, this project concentrates on the vehicle steering calculations which can be modified to enhance the performance and facilitate driver control. The various parameters on which the geometry depends are listed below. Design of stub axle length, steering arm length, angle between stub axle steering arm, design of triangular plate which is also called as pitman arm, steering column, knuckle bolt, knuckle, tie rod, vehicle width, track and wheelbase, vehicle weight, understeer and oversteer conditions, turning radius and Ackermann angle. These parameters also depend on other selected parameters which are being listed below. Material used for different steering components considering their properties. Mild steel for knuckle, steering arm, tie rod, pitman arm, AISI 1018 pipe for steering column, EN8 for stub axle. Even driver body angle considerations are very important considering torso, knee, back, elbow angles. Chassis considerations such as track width, which is front track width, rear track width, along with wheelbase, distance between pivot, assuming turning radiuses. Total mass consideration of vehicle of cart along with driver acting on the front wheel and acting on the rear wheel are also important. Steering geometry calculations. Following the other parameters, we have calculated these different parameters and stated their dimensions below. Wheel track, wheelbase, inner turning angle, outer turning angle, inner turning radius, outer turning radius, Ackermann angle, Ackermann percent, length of the tie rod, steering efforts at static, steering efforts at dynamic, caster camber, kingpin inclination and toe in toe out angles also. These are the visual representations of which we were talking about: the stub axle, the C clamp which we call as knuckle, and here are all the parameters calculated from the formulations of the references. This is pitman arm, this is tie rod, and here are all the parameters which are being calculated considering the formulas. Here we can see steering system analysis report which is called as CAE report, in which loads are being act on the various points on the components which are being indicated as red in color, and this indicates the maximum stresses on that point. The stresses considered are into 3 taken in the calculations. This is the visual representation of kingpin and caster angles, as the caster angle applied can be seen from the side view of the vehicle and the kingpin inclination angle can be seen from the front side of the vehicle. The caster here considered is 15 and the kingpin considered here is 12. Considering the implementation through manufacturing process, this is the kingpin to kingpin measurement taken on the chassis. This is the kingpin concept. This is the knuckle fixture, and also to connect the knuckle with the chassis, these are the various fixtures designed and are some of the top view side views of the fixtures design. Hence we have manufactured components: tie rod along with the rod ends, knuckle with chassis, stub axle, steering hub, column end support, pitman arm. Here is the stub axle. It considers top view, front view and front view from steering arm. Stub axle considers of various parts from rear end, the nut, the spacer, the length on which the wheel is being going to lie, the spacer again, the steering arm, the kingpin point, where the kingpin inclination and caster angle been acted. Here we would like to conclude in this paper presentation the best to the knowledge basis with design calculations and assembly of the F9 steering system is gathered with the help of researchers and their documentations. The purpose of the steering system, their objectives, selection of the steering system, material used in various steering components, calculations related to various components of the steering system for Formula 9 vehicle were studied. Ackermann steering system is its geometry components were designed in SolidWorks by varying the different parameters until a precise geometry was obtained, considering the calculations. The final design of all the components are calculated considering different parameters and assumptions and they are manufactured respectively. An optimum design calculation procedure was followed and hence can be considered as a standard procedure for designing steering system of vehicles like F9. This is the autocross testing video of our steering system of our Team Piston Arts, Saraswati College of Engineering, Kharghar, GKDC, which scored an overall All India rank 8th, organized by ISNE at Karimoto Speedway, Coimbatore. As you can see, the vehicle is been going through various cones set at a various parameters measurement given by GKDC for testing the vehicle capability and ability of steering, considering the acceleration and braking of the vehicle. We would like to thank our references from which we have used the formulas to derive and design and manufacture all the various components of steering system for our project. Thank you.